Hi, everyone, and welcome to today's workshop, Respond Instantly, Gain Real-Time Insights from Logs, Metrics, Traces, and Events. Before we get started, I'd like to go over a few items so you know how to participate. We are recording this workshop and we'll be sending out a link to the recording afterwards. All attendees are in listen-only mode. However, at any point during the presentation, you can submit a question by typing it into the questions pane of the control panel in the upper right-hand corner. We will collect these questions and address them during the Q&A session at the end of the presentation. So without further ado, I'd like to introduce Steve Waterworth, Technical Marketing Manager at Instana, and Craig Vitter, Director of Global Presales at Humeo. Take it away, Steve.
Hello, and good morning or good afternoon, depending on your time zone. So today we're going to have a quick look at Instana and Humeo and how they work together. We'll start off with a bit of background on Instana and Humeo, what they are, what they do, how they work together. But then the bulk of the presentation will be a little bit of a workshop as to how you set it up, get the integration going, and then use it in some real-world scenarios. So first of all, what is Instana? Instana is automatic observability for all your application components. And this will work whether you're state-of-the-art microservices, Kubernetes clusters, or your more legacy applications, if you've still got some monolithic WebSphere, WebLogic servers, Oracle databases, that type of thing, it'll still work just as well in both environments. So what it's going to do, there's an agent. So the agent gets installed on the operating system or your Kubernetes cluster, and that agent, once running, performs automatic discovery. So it'll look, see what else is running around it, anything it recognizes, it will connect to and start monitoring. So for things like data stores and caches, it's going to be pulling performance metrics out. For language runtimes, it's going to be tracing every single request, no sampling. And through the language instrumentation and the logging frameworks, it will extract log messages at 1 and above. So as well as doing all that automatic monitoring, distributed tracing, the data from the tracing is what's used then to build dependency maps and flow maps for the various services and components. All those traces, all those metrics are continuously analyzed in real time, and anomaly detection is performed. So anything that goes a little out of bounds, we're going to alert on that. So it'll also do root cause analysis. Because of the dependency discovery, Instana knows what's talking to what and where it's running at any point in time. So when you have a large distributed system with many cross dependencies, one little problem downstream can have a massive ripple effect up, causing problems upstream. And traditional alerting is going to alert you on everything. So this is where the classic alert storm comes from, and your inboxes or your Slack channel is suddenly filled up with 100 alerts, and you've no idea really which one's cause and what's effect. So as I said, using that automatically discovered dependency, Instana can then navigate that dependency tree and work out what's cause and what's effect. So what you'll receive on your Slack channel or in your inbox is a single event, which is highlighting the root cause and the cascade effect. And of course, that's all part of the alerting. So there's various alerting channels that Instana will go out on. So Instana has very high resolution data. The metric data comes in at 1 second granularity and is retained for 24 hours. And every single request is traced. There's no sampling either at the front or at the back. And every request is maintained, or every trace of every request is kept for 7 days. And all that happens with only a few seconds lag behind real time. So in a highly agile environment where you're doing multiple releases per day, you've got very high density data as you're doing those releases. So that, and with very little lag. So that allows you to very quickly make an informed decision whether to continue rolling out that release, or if the release is a bit of a disaster, stop the rollout, roll it back, and avoid the disaster. But because you've got that high resolution data, which was captured even if that release was only live maybe for a couple of minutes, you've still got all that high resolution data available for a post-mortem after the event. Instana offers very simple pricing. It's a single price per operating system instance, and that's whether that's physical or virtual. There are no extra charges for the amount of data you send to Instana or the number of users of the Instana UI. So if you have a particularly busy period, say maybe if you're retail on a Black Friday or Christmas, then you're not going to have a nasty surprise the following month when Instana sends you a big bill. That just doesn't happen. It's a single flat price. You can check that out on the pricing page on the website. And now over to my colleague Craig, who will explain what Humeo is.
Thank you, Steve, and thank you everyone for joining us today. Humeo is a great partner to Instana because we allow you to go deeper and back in time to see all the data correlated with what Instana is showing you, because Humeo is a generic log aggregation platform that's available either for self-hosted utilization, or you can also use our software as a service cloud version of Humeo. Humeo allows you to search your logs without ever having to index them. We can ingest structured and unstructured data and metrics as well. Obviously, we can ingest data from Instana, and we give you near real-time access to that data while still being able to ingest tens of terabytes per day, with some of our customers approaching 100 terabytes per day currently. With all that done, we can easily integrate with your existing environment, for example, with Instana, or if you're using log shippers today, like any of the Elastic Beats, Splunk, HEC, RSys log, you name it, we can probably use it out of the box today. And all while doing that with 60 to 80% less hardware than comparable solutions in the marketplace. Next slide, Steve. And so some of those benefits of the index-free logging of Humeo is that we are able to give you access to data streaming, so essentially real-time sub-second latency while ingesting tens of gigabytes a second, and real-time alerting on that data as well. So being able to alert nearly instantaneously upon receipt of data if that's warranted, while giving you ad hoc searching capability, including the ability to do field extraction while you're querying. So even though we're parsing that data out when we're ingesting it, you're also able to reparse the data while you're querying it if that's something that you need to do. And we can also do that while giving you access to high cardinality data, and all at a lower total cost of ownership than comparable solutions.
Okay, thank you very much, Craig. So now to the workshop section of the presentation. So we'll take you through how to set that up and how to use it once it's set up. So the environment I'm using, obviously Instana and Humeo. If you want to play along afterwards, then you can go to instana.com, sign up for a free trial, and also go to Humeo and sign up for a free trial. So that gets you the two data engines. The application I'm using for the purposes of this demo is Stan's Robot Shop. This is a free sample microservices application. It's hosted on GitHub. And if you want to run that, you can run it on your developer's workstation using Minikube. You just need to allocate 4 CPU, 4 GB of memory, and that's enough to run Stan's Robot Shop and a few other bits and pieces that make all this work. Of course, you can always run it on Google Compute or AWS as the Kubernetes provider of your choice. As Craig said, Humio is very open to ingest data from various sources, and in a Kubernetes environment, as part of the Cloud Native Foundation, FluentD is the sort of the log shipper of choice. So I've provided in my personal repo, Git repo, the deployment files and Docker file I'm using to build the FluentD and deploy it out into the Kubernetes cluster. So that's all the source files you need if you actually want to set this up and have a little play with it yourself. So if you do get everything installed, and this is what I've got running here, we'll see it very shortly. So you end up with Kubernetes, with Stan's Robot Shop, the Instana agent deployed into there as well, and that's going to do its auto detection, pick up all the components in the Kubernetes environment, start monitoring those, and ship the data off to the Instana backend. FluentD is the log shipper, so that will run and that will be grabbing all the container logs that are running inside Kubernetes there and shipping those off to Humeo for indexing and querying. So to set up the integration, once you've got everything running, you need to tell Instana how to connect to Humeo. So you specify where Humeo is. If you're using the free trial, you'll be on their SaaS platform, and that's what I'm using here. So it will be cloudhumeo.com. Obviously, if you're running it on-premise or in a VPC or something, then you need to put the appropriate IP address or name in there to go find that. Then the name of the repository you're using, Humeo has multiple index spaces. So the one I'm using, imaginatively entitled Demo Instana. So once you fill those details in, there's a link at the bottom. You can click on that, test that the link's working, save those changes. And once you've done that, you'll see that the Humeo button will then appear in various places in the Instana UI, which allows you to go from the Instana UI to Humeo in context. So you'll be looking, in this case, we're looking at a Kubernetes pod. So we're using the unique ID of the Kubernetes pod to take us into Humeo with the search field pre-filled, so we get just the logs for that pod, and also the time range will sync as well. We're looking at the last hour in Instana, so when you're in Humeo, you'll also be looking at the last hour, same for any selected time range. And of course, it's bi-directional link, so you want to be able to go back the other way. May look a little horrific, but you actually only need to do this once as you're building your dashboards out. So essentially we have a magic link back, which will be your Instana tenant back, and you send data, so basically key data from the log entry back to Instana, and Instana then automatically finds all the appropriate entities that match, be it a Docker container, a pod, a JVM, a host, whatever it happens to be, and then it lists those up as possible drill downs for you to go investigate more. Additionally, you can link back into Instana via dynamic focus query. So this is another way of hopping back from Humeo by building that link up and populating a suitable dynamic focus query, which will again take you back to the right place in Instana in context, so you can continue your investigation. So that's all the theory. What does it look like in practice? If I just pop out of there and we'll go into the Instana UI. So here we are on the Instana dashboard, and we're looking at the events. So these are all the alerts that are currently active. We're looking at the last hour here. We can see on the time range at the top there. And we have a particular problem here on the payment service at the moment. If I click on that event, we can get a bit more detail. if I actually click on the time range, we can then shift our time range to be actually when this event happened. And opening that event up, yeah, we can see the data behind the trigger, behind this alert trigger. And yes, the error rate on the payment service here did spike up at 100%. It's since dropped down again, but there's the odd little sporadic thing. So we've obviously got a bit of a problem with that payment service. So this is the type of information that you would receive via your Slack message or email or PagerDuty, whatever it is you're using to deliver alerts. You'd get this level of information and then allows you to drill straight into that. So let's go take a look at that payment service. And yes, there we go. We can see that indeed there are quite a lot of errors happening. So remember, we're picking this up from the trace analytics. So every request is traced. Those traces are analyzed in real time to produce this data. So here we have our KPIs, our rates, errors, and duration, and we can see that high error rate. We can then start our investigation. So we take a look at the flow here. So is this error actually coming from the service, or is it rippling up from a lower level? If I highlight the flow by errors, we can see that yes, the payment service is shining away with a high error rate. The other services are fine with a 0 error rate. So all our errors are happening actually inside the service. They're not an error from a downstream service bubbling up. If you remember at the beginning, I said that the language instrumentation that Instana performs, we're going to instrument those standard logging frameworks, and we're capturing any log message at 1 or above. So here we've captured an error message or error messages at error level, and it looks like some sort of runtime error here. It's actually a Python service we can see, and we've got this runtime error from our Python. Drilling down on that error message will take us then to the analytics part of Instana. This is where we can search through all the collected traces by various ways and means. And by clicking on that link, it's taken us there with the search pre-filled in. So here's all the matching traces that have that particular error message in and are from the payment service. So we can see the URL that was called. Drilling in to one of those traces, yeah, it is a trace that has an error. The error was at the top level here, and we get the timings. So we can see that the request was called, it made a call to another service. This was good. Notice no error on this one. This was good. It made a call to a data store, returned, and then we got that nasty error message. So we know the timings when that error happened, and we know that the downstream calls were good. We saw that in the flow as well. Scrolling down, we can see the error in more detail. And there's our error message, and there's the stack trace as to where the error came from. So this is the user code here as opposed to framework code, and I can click on that little code snippet there, and we get access to the source. As this is Python, of course, it's just reading the text file, but this also works for Java, for example, where it'll decompile the code and you'll get that code back. So this allows us to have a quick look at the source code and try and figure out what's going on. And we can see actually that at the beginning of the code is actually a info statement. And of course, Instana is only doing 1 or above. So this is really where then that integration with Humeo really comes in. Quite often there's useful debugging information at a lower level in the logs. And of course, not everything is language runtime. Things like data stores and caches will also be logging, and there may be useful information in there. So if I expand the infrastructure stack, we can see where this particular trace was handled, or this request was handled, and we can go directly now to the Docker container where this code was running. So we get the view of the Docker container, metrics associated with that. And of course, we have our Humeo link. So clicking on the Humeo link will take us then to Humeo in context. So we're looking for that particular container ID. And then we have timestamp and logs just to make this a little clearer. If I just filter that down, makes it a little easier to read. So now we can troll through and we've got our various info statements and we've got some error statements here. So there's our error message from the traces. So they're looking at how that flowed. We can see the info message and then the view of the cart object that was sent, and that's not looking so good. If we look at a better one here, so this is from a different user, and then look at the cart object that was sent, much more complete. So it would appear that this particular integration partner here is sending us malformed shopping carts. Our code is not really set up to handle that as elegantly as it should, and then we're running into that non-type runtime error. So you can see that using both Instana and Humeo together to get all the information you need to help find the root cause of this particular problem. Of course, what we can do now is go fix that code, rebuild the container, push it out, and use Instana to monitor that rollout. And because we get all that high density data with a very little time lag behind real time, we can then very quickly make a decision as to how well that fix is working or not. You know, maybe we fixed the errors but messed up performance, or maybe we didn't fix the error, but we would know very, very quickly with Instana whether that was the case or not. So that's one use case of going from Instana into Humeo, but we can of course go the other way. So I've got some dashboards here. So here, this is using Humeo to analyze the Nginx Access Log. Nginx is the Ingress proxy for our Kubernetes environment. So every request is going through Nginx. So we can see which particular services, let's just make this stop it auto updating, just fix the time on that. So we can see then that the rating service is by far the most popular. There's a bunch of other services in there as well, but the ratings is the most popular one. I can filter the lower table by service name. There it is. So here's now all the requests through to ratings, and we're building the dynamic link out here in this column. So this now then allows me to go in context from Humeo to Instana. So it's using the key data that was provided in that link to find entities that match. So I can go straight now to the Kubernetes pod that we found, and again using the context guide, we can quickly navigate then to the service that this particular pod is providing. So the logical service, so i.e. the requests and the traces. So again, we get our rate, errors, and duration. So we can see what's happening in this particular service. We can go take a look at the endpoints of the service. All endpoints are automatically discovered and tracked. Then we can, so the get endpoint is by far more popular than the put endpoint. So that's using one navigation, then back the other way, going back in context. And of course, we could go again back through the stack into Kubernetes, and we should have our pod. And we go to the pod, and again, we've got the link back. We could go round and round in circles forever. So that's a very quick run through of how Instana and Humeo work together to really help you make the most of your diagnostic data and get to root cause as quickly as possible. So hopefully that's answered a few questions for you, but I'm sure there may be some more, so probably time to go to the questions. What has arrived whilst I've been talking?
Thanks, Steve. So we're going to begin answering questions submitted during the presentation. As a reminder, you can still submit questions through the questions pane in your attendee control panel on the right-hand side. Our first question is, how do the log ingress and egress charges work?
That sounds like a question for Craig.
Oh, great. So Humio charges based on the total ingest per day, and that's usually going to be measured in gigabyte or terabytes. So it's just an average of what you are going to ingest per day in volume. Ingress and egress, that's going to depend on whether you're using our cloud or you're hosting Humio locally within your data center. If you have Humio within your data center close to where the data lives, you're not going to be charging yourselves ingress or egress on that data to get it to Humio. Now, if you have data in a data center and you're using our cloud service, there's going to be some cost, obviously, in terms of bandwidth to move it to Humio. That's not something we charge you. That's more something you just have to take into account with how much data you'd be shipping to us.
Great. Another question was, will Humio or Instana be able to parse XML logs and provide alerts?
So on the
Shall I
Humio
take that?
side, oh,
On, you take it first, and then I'll answer the Instana bit.
okay. On the Humio side, XML parsing is built into Humio, so there's no additional work there. It's quite easy to parse XML, and yes.
So yeah, from an Instana point of view, because the log capture is done inside the language runtime, we're essentially capturing the message at the point in the code where the log.error call is made, or the log.warn call is made. So we're picking up at that point the error level and the message string. So that's before then the logging framework has formatted the message into XML, JSON, or text. So we'll still pick that message up, and it'll be there searchable and as part of the statistics.
Great. Another question came in that was asking, how does Instana's dynamic graph factor into this workflow?
Okay, well, we saw a few practical examples there of actually using the dynamic graph. So the dynamic graph is the database that keeps track of what's talking to what and where it's running. So that gives us a lot of context. So that's useful for the root cause analysis, but it's also just useful for getting around the UI. So we're looking here at this ratings, which is a Kubernetes pod, expanding this stack pop down here. And this is essentially that view into the dynamic graph. So that tells us straight away that this guy's running inside this cluster on this particular Kubernetes node at this time, is part of this namespace, is controlled by this deployment, and is mapped through to this Kubernetes service. From an application point of view, it's running this actual service, and similar data again for the infrastructure, so we can get straight to the Docker container, or for example, we could go look at the process. So this is the data from the operating system process. This guy pops up all the time and really makes, from a user interface point of view, makes it so much easier to hop around as you want to look at different aspects of your environment.
Okay. Another question was, can an alert trigger an automatic action? For example, add more resources.
Yeah, probably the easiest way to do that would be via a webhook. So any alert can be routed out through an alert channel. You can have many channels. So it's just down to, and one alert can go out through many channels as well. So a particular alert could trigger, and the channel it would go out would be a webhook. Something then would receive that webhook and make the appropriate adjustment.
And that works in Humio just as almost exactly the same as it would as in Instana. You'd be able to trigger alert in Humio and fire off a webhook.
Okay, another question that came in was, how can I configure the Instana agent in my on-premises bare metal cluster?
Okay, so the Instana agent works the same. It's just how you actually deploy it that varies. So depending on your environment, in fact, if we go to the agents part of the Instana UI here and go to the install, you can see there's various different install options. And if we go, say, to a bare Linux box, you can go very old school, download a zip file, unzip it, and copy the files in place that way. But also, if you have a look here in the supported operating systems, the Instana agent is available in the package registries for those various operating systems. So you can use the regular operating system tools you would, such as apt-get or yum, to do the agent install on your bare metal. And then the agent runs the same. Once that agent is up and running, it's going to look around it, see what else is running in the environment with it. Anything it recognizes, and there's over 100 things it will recognize, it'll connect to and start monitoring and pulling metrics or traces or both out of those components.
Great. Another question was, how do you create sensitive alerts for a production environment?
So you can create your own alerts. There's Instana ships with a whole bunch of pre-configured alerts, which will capture all those sort of common use cases. So all those things like the CPU's too high, or the garbage collection in your JVM spending too much time doing garbage collection, all those sort of standard things, they're baked in. But of course, that only gets you part of the way there. There's always something unique about each application that's no way we can know in advance. So maybe, I don't know, you've got a particular message queue, and if it's deeper than 5, that's a bad thing, and you want to alert on that. Yeah, of course, you can configure your own manual alerts. You can select any number of metrics and use various comparisons against those metrics. So you've got your real basic if X is greater than Y, but there's also other detectors in there, such as edge detectors, which will detect a sudden change in either positive or negative. So maybe you've got a service which regularly ticks away at maybe 5–10% errors, and that's normal. But if it suddenly jumps up to 30% errors, then that's a bad thing. So that'd be a great example of using like an edge detector where you're not entirely sure where to set the threshold, but a sudden change in the behavior is a good leading indicator that maybe something's broken. So yeah, very easy to configure your own alerts.
Thank you. Another question is, how does Humeo achieve good speeds without indices?
Without indexes, yes. That's a great question. So Humeo is definitely designed from the ground up to work without indexes. The Humeo architecture specifically focuses on parsing the data into fields. Those fields are not indexed, but when we store the data on the back end in our time series database, it is a time series database. So it is very much architected based on time and the source of the data, and done in a way that it's compressed to 10 or 20x on average compression, so that we're moving much smaller chunks of data, and we're doing it through a MapReduce process across the cluster, so that when you query the data, all of the nodes in the cluster are partaking in grabbing the segments involved and answering that query. They're moving smaller chunks of data than you would in a system with indexes, and it's just optimized from front to back in order to achieve a high speed throughput. Now, on the front end, when the data is ingested before it's ever written to that time series database, it's already parsed and it's in memory. So the querying that you're doing and the alerting you're doing on that fresh data that's just arrived at Humio is actually on a stream, right? So we call those live queries. That's data that's in memory. It's streaming into Humio, and you can actually look at it before it's ever been written to that backend time series database. So it's optimized to get data to you quickly and sub-second latencies, and also to be able to efficiently read historic data as well. And there's a few more tricks behind that. So if you're looking for data 1, 2, 3 years out with high cardinality, we've got some other filtering technology that allows us to do that. And not sure we have enough time here to go through the full architecture, but would love to have that conversation in depth with you.
Another question that came in is, will Instana work with applications that are not containerized?
Yes, it will. So if you are containerized, great. If you're not, still great. If you're running applications just native on a box, or be that physical or virtual, the agent will still work in exactly the same way. It'll see what else is running around it. Anything it recognizes, it connects to and starts monitoring it.
Okay. Another question that came in is, what's the typical retention and volume to get the best query performance in Humio?
Great question, and it's really not based on retention at all. So query performance in Humio is going to be based on a couple of factors. It's going to be based on the amount of data you're ingesting versus the hardware in the cluster that's receiving that data, and that's CPU, memory, and your storage. So for the current data that's in memory, that's going to be fast pretty much regardless, because the in-memory data is going to achieve, really milliseconds in terms of query latency. But Humio supports multiple tiers of storage. So ideally, the fastest performance will come from the fastest storage devices. So for example, if you have access to NVMe drives, it's actually what we use in our cloud. And for the short term, we move data from memory into these NVMe drives, which are ephemeral. And then as those drives fill, older data will get aged out into SSDs. So that's still super fast, but slightly slower. And then we also support multiple layers of storage like that. So as you go back in time, if you have lots of fast drives, your performance will be consistent across the query spectrum. But if you were to say to implement storing data in Humio on like an EBS volume on Amazon, that would be a bit slower than an SSD drive, right? So it's really, query performance is going to be based on your hardware, your storage speeds, and that more than how much data you have and your retention periods.
Great. Folks, we still have another minute or two if you want to get a question in, but I'm going to ask one more to Steve, and then so get your question in if you want. Another question that came in was, can I add additional metadata to Instana traces?
Oh, good question. Yeah, so Instana tracing is built on top of open tracing. So the open tracing API is available to you. So it's very easy then to get hold of the current trace context and add additional metadata, and also add additional spans. So maybe in your code, there's a particular function that you want to track how well it's performing. Maybe it's doing some complex maths. Then you can put a start and end span around that, and that will show up as a child span then inside Instana. Instana is also fully standards compliant, so if you've already instrumented all your code with open tracing, you can then just swap out the open tracing implementation and plug the Instana tracer in and leverage the work you've already done. It will also ingest Jaeger and Zipkin traces, and also the new open telemetry standard as well. And we're on the standards panel for trace context. So once all that's ratified, we'll be supporting that as well. So yeah, very open on the tracing. You can do pretty much anything you want. Ultimately, there is in fact a simple REST API for tracing. So you can even trace your shell scripts if you wanted to. Not sure that you would, but it is technically possible.
Thank you. Well, I'd like to thank all of our presenters today, and thank you everyone for attending today's workshop. We'll be sending out a recording of this presentation within the next couple of business days, so keep your eye out for that. And we'll be drawing a name from the attendee list and emailing the winner for the AirPods Pro. We hope you have a great rest of your day, and again, thank you for joining.